Welcome back to the Prompt Index podcast. Today, we're diving into some groundbreaking research that explores how large language models, or LLMs, can assist with a crucial task in software development, detecting and repairing bugs and security vulnerabilities in code. This research comes from a talented team of authors, Akshay Mhatre, Noujoud Nader, Diehl, and Deepti Gupta. So, what's the main problem they're tackling? While LLMs like ChatGPT-4 and Claude 3 have shown promise in various programming tasks, their effectiveness in addressing real-world, complex software bugs, especially security-related ones, hasn't been thoroughly vetted. Considering the increasing risks of functional failures and security breaches in modern software, this research is essential. The authors set out to perform a systematic evaluation of 3 leading LLMs, ChatGPT-4, Claude 3, and LLM-4, using a challenging benchmark. This dataset isn't just a compilation of random code snippets. It includes real code from reputable projects like Seed Labs and OpenSSL, focusing on foundational errors, classic vulnerabilities, and advanced production-grade bugs. They developed a novel multi-stage, context-aware prompting protocol to simulate realistic debugging scenarios. Each model was evaluated on its ability to detect bugs accurately, provide insightful reasoning, and suggest quality remediations. And the results? Well, they found that while all models excelled in detecting simple issues in structured code, their performance dropped when faced with more complex security vulnerabilities. Host ChatGPT-4 and Claude 3 emerged as the top performers, delivering nuanced analyses that considered the broader context of potential vulnerabilities. In contrast, Llama 4 sometimes struggled with deeper reasoning, highlighting a significant gap in understanding security implications. The implications for this research are huge, particularly in educational settings where LLMs can provide real-time feedback and assist novice programmers. However, the researchers note that the current limitations of these models mean they aren't yet ready to replace comprehensive code review practices. Host the future, the authors plan to investigate multi-agent systems to improve bug detection workflows and explore other programming languages to evaluate the generalization of these findings. Overall, the research illustrates that while LLMs are evolving as valuable tools in code analysis and auditing, we're still on the journey toward their full potential in combating complex software bugs. Podcast outro music fades in. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free resources at the Prompt Index. You'll find the link in the description below. Until next time, Serp World.